There could be 36 communicating intelligent civilizations in our galaxy, study says. Earth has proven unique in its ability to host life in the universe so far, leading us to question if we're truly alone. Maybe we're not. Scientists have calculated that there could be a minimum of 36 active, communicating intelligent civilizations in our Milky Way galaxy, according to a new study. However, due to time and distance, we may never actually know if they exist or ever existed. The study published Monday in the Astrophysical Journal. Previous calculations along these lines have been based on the Drake equation, which was written by astronomer and astrophysicist Frank Drake in 1961. Drake developed an equation which in principle can be used to calculate how many communicating extraterrestrial intelligent (CETI) civilizations there may be in the galaxy, the authors wrote in their study. However, many of its terms are unknowable and other methods must be used to calculate the likely number of communicating civilizations. So scientists at the University of Nottingham developed their own approach. The key difference between our calculation and previous ones based on the Drake equation is that we make very simple assumptions about how life developed, said study coder Christopher Consolis, a professor of astrophysics at the University of Nottingham, in an email to CNN. One of them is that life forms in a scientific way, that is, if the right conditions are met then life will form. This avoids impossible to answer questions such as what fraction of planets in a habitable zone of a star will form life, and what fraction of life will evolve into intelligent life, as these are not answerable until we actually detect life, which we have not yet done. They developed what they call the astrobiological Copernican principle to establish weak and strong limits on life in the galaxy. These equations include the history of star formation in our galaxy and the ages of stars, the metal content of the stars, and the likelihood of stars hosting Earth-like planets in their habitable zones where life could form. The habitable zone is the right distance from a star, not too hot or too cold, where liquid water and life as we know it may be possible on the surface of a planet. Of these factors, habitable zones are critical, but orbiting a quiet, stable star for billions of years may be the most critical, Consolis said. The two astrobiological Copernican limits are that intelligent life forms in less than 5 billion years, or after about 5 billion years, similar to on Earth, where a communicating civilization formed after 4.5 billion years, said coder Tom Westby, an assistant professor in the University of Nottingham's Faculty of Engineering, in a statement. The astrobiological Copernican strong limit is that life must form between 4.5 to 5.5 billion years, as on Earth, while the weak limit is that a planet takes at least 4 billion years to form life, but it can form any time after that, the researchers said. It is called the astrobiological Copernican principle because it makes the assumption that our existence is not special, Consolis said. That is, if the conditions in which intelligent life on Earth also developed somewhere else in the galaxy, then intelligent life would develop there in a similar way. Based on their calculations using the astrobiological Copernican strong limit, they determined that there are likely 36 active and communicating intelligent civilizations across our galaxy. This assumes that life forms the way it does on Earth, which is our only understanding of it at the moment. It also assumes that the metal content of the stars hosting these planets are equal to that of our Sun, which is rich in metals, Westby said. The researchers believe the strong limit is the most likely because it still allows intelligent life to form within a billion years after it did on Earth, which seems like plenty of time, Consolis said. Another assumption of these potential civilizations is that they're making their presence known in some way via signals. Currently, we've only been producing signals like radio transmissions from satellites and televisions for a short time. Our technological civilization is about 100 years old. So imagine about 36 others doing the same thing across the galaxy. The researchers were surprised that the number was so small, but not zero. That is very remarkable, Consolis said. Even though this study only looked at our galaxy, distance is an inhibiting factor. The researchers calculated that the average distance between these potential civilizations would equal about 17,000 light-years. Detecting those signals or sending communications using current technology would take so long that it would be nearly impossible. The search for intelligent life is only expected to yield a positive observation if the average lifespan of communicating extraterrestrial intelligence within our galaxy is 30-60 years. That is to say, our communicating civilization here on Earth will need to persist for 61-20 years beyond the advent of long-range radio technology, approximately 100 years ago, before we can expect a search for extraterrestrial intelligence two-way communication. Under the more relaxed assumptions of the weak Copernican case, there would be a minimum of 928 civilizations communicating in our galaxy today, according to the study, meaning more of them at closer range. This would only require about 700 years to make a detection. Lifespan of a civilization. It is clear that the lifetime of a communicating civilization is the key aspect within this problem, and very long lifetimes are needed for those within the galaxy to contain even a few possible active contemporary civilizations, the researchers wrote in their study. And then there's the question of survival. Are other potential civilizations as long-lived as those on Earth? If the search for this life reveals nothing within a distance of 7,000 light-years, the researchers suggest that this could mean one of two things. First, it could suggest that the lifetimes of these civilizations are shorter than 2,000 years, which could mean that our own is nearing its end. Second, it could suggest that life on Earth is unique and occurs in a much more random process than the astrobiological Copernican limits established in the study. Not all factors or limitations were included in the study, like the fact that the small M-dwarf stars, these Earth-like planets, may be orbiting, may release harmful radiation that would make life difficult to exist, which is a debated issue, Consoli said. M-dwarf stars are common in our galaxy and have been known to host rocky, Earth-sized planets. Next, the researchers will look beyond our galaxy to see if life may exist outside of its boundaries. Our new research suggests that searches for extraterrestrial intelligent civilizations not only reveals the existence of how life forms, but also gives us clues for how long our own civilization will last, Consoli said. If we find that intelligent life is common, then this would reveal that our civilization could exist for much longer than a few hundred years. Alternatively, if we find that there are no active civilizations in our galaxy, it is a bad sign for our own long-term existence. By searching for extraterrestrial intelligent life, even if we find nothing, we are discovering our own future and fate. Click subscribe to receive the latest news.